Good morning, everyone, and thanks for having me. My name is Matthias, and together with you, I want to do a deep dive on Chrome DevTools for agents. In the next half hour, I'll cover what it is and what you can use it for. And we'll explore how one of our partners has deeply incorporated it into their workflow for a 10 times efficiency gain. Let's get started. This here on the screen behind me is Chrome DevTools. It's what opens when you right-click and hit Inspect in Chrome. DevTools is what you'll trial and error around in to find the right combination of CSS properties to get all the new CSS features like anchor positioning, view transitions, and more actually working. In September last year, the same DevTools we all know and love got a new UI surface, additional to what you'll get when you right-click Inspect in Chrome. DevTools for agents. Let's dive in. We're going to start with a general overview of what Chrome DevTools for Agents is, where it lives, how it relates to your other tools, and how your agent can actually use it. Then we're going to look at the foundational technologies that enable the capabilities of DevTools for Agents. Having a basic understanding of those will be the foundation to understand the actual capabilities and use cases. Before we look into the various configuration options and finally how you can get started yourself. But first, we are going to do some time travel. I want to take you all on a brief virtual tour back in time to the beginning of your career, wherever this was. Maybe it's been a couple of months ago, 3 years, or decades. It doesn't even matter. Just try to think how it was as an absolute beginner web developer. For me, this was in 2014. This was me back then, my first corporate profile picture on the day I joined as an apprentice web developer to learn web development. I was part of a team of around 20 other web developers who were taking turns in teaching me development over the course of 2 years. The one thing all my colleagues had in common is that they used DevTools to show and demonstrate things to me. For example, I learned that the static HTML from my code editor turns into a dynamic living thing called DOM by clicking through the Elements panel. Later in my career, I learned about web performance by running Lighthouse audits over and over again and just blindly following the advice it gave me until the scores turned green again, without really understanding the background. So for me, DevTools enabled a closed feedback loop during my learning journey. Through DevTools, I could inspect the live page I was working on, fiddle with it, try and break things, debug issues. And this has been true for me just as millions of other developers, including you, before and after us. But there are a few developers who learned web development without ever touching DevTools. They are over 3 years into their career, and they're doing a fairly decent job, I would say. But they never touch DevTools. I'm talking about coding agents, obviously. We think they're missing out and could do more if we give them the right tools. We believe that giving your coding agent access to DevTools through DevTools for Agents enables the same closed feedback loop we benefited from our whole careers. Let's look at a debugging example, the way you would manually debug and handle it, even with AI. This is a sign-up form using a company's internal auth provider called Showtime. It's not publicly documented, so no AI model would know about it. When I try to register and it fails, I only get cryptic error messages like app error 1003. Your out-of-the-box coding agent runs into a bunch of dead ends debugging an issue like this. First of all, it would rely on you to manually surface the issue. But then also, if you actually surfaced it and you prompt, please fix app error 1003 in sign-up form, TSX, when trying to sign up with your coding agent, it can't do much. It will search for app error 1003 across the code base and then likely just spiral. If anti-gravity here got lucky after some digging, it might find this lousy to-do comment I left for it. To do, handle specific error codes. Great and helpful, right? Little does my coding agent know that the solution is actually not too far. Any wild guesses from the audience where it is? Is it A, in the training data, Is it B in the source code, or is it C in the runtime data? Let's do a quick show of hands. Who's for A? Okay, one person. Who's for B? Again, one person. And who's for C? Yay! So after you listen to my heartwarming story of how I became a developer, you will know it's C. The solution is in the runtime data. Let me show you where. When I'm submitting the sign-up form, a request is being sent to an API. And as you know, all network requests sent from a page are surfaced in DevTools. It's the same here. So when we look in the network panel in DevTools, inspecting the failing request, and look at the response preview, we see there is actually an additional message that we can use to give the user more information. And not only we can use those network requests, but our coding agent as well. Giving our coding agent access to this information through DevTools enables this closed feedback loop I mentioned before. But let's see if that's true by giving it a test run. Before we can do that, we need to tweak our prompt ever so slightly. Instead of asking our agent to look at specific files, we ask it to look at the runtime. As DevTools for Agents has access to source maps, it will be able to guide your coding agent to the right file anyway. So we are going with go to localhost/signup, debug and fix the error when signing up with test and 1, 2, 3, 4. Using this prompt with my coding agent and DevTools for Agents enabled, we'll start a full end-to-end fixing flow. The agent will open the page in a real Chrome instance, try to log in, capture any console logs or network requests, and combine all the pointers to actually fix the code. That's the power of DevTools for Agents. All right, so after you've seen this first example of what Chrome DevTools for Agents can do, let's briefly look into the foundation that enables this all, as this will help you to get a better understanding of the use cases we'll explore in just a minute. So while DevTools for Agents is fairly new, it's actually built on a pretty solid and long-standing foundation using tools the same team has been maintaining for years. Chrome for testing and Puppeteer. But let's break it down. At its core, DevTools for Agents is an NPM package that you can install on any machine that has a recent Node.js version. This is what your coding agent is using. May it be anti-gravity, Cloud Code, Codex, or whatever you prefer. Your agent might either use it through the MCP server or the CLI, which both ship as part of the same NPM package. The CLI enables your coding agents to script against DevTools for Agents, which can be more token efficient compared to using it through the MCP server. The third and last key thing that brings it all together is a set of skills, which teach your coding agent how and when to use Chrome DevTools for Agents. For now, Chrome DevTools for Agents ships with a total of 6 skills, which can be roughly put in 2 categories. The troubleshooting and the Chrome DevTools and Chrome DevTools CLI skills help your coding agent to understand key capabilities, concepts, and general usage. The accessibility debugging, the memory leak debugging, and the optimized LCP skills include expert knowledge in that specific area, making your coding agent an expert in the same. Those skills are what bring this all together, at least in the context of debugging. But what about building to begin with? This is what we created Modern Web Guidance for. Modern Web Guidance is a comprehensive and expert-vetted set of skills covering all of Chrome's best practices on building for the modern web. The package embeds decades of Chrome's web platform expertise directly into your coding agents. And because it's based on skills, it works with any coding agent out there. I know there are dozens of people currently promoting their own skills, but let me briefly show you why this one really matters. My colleague Phil built this little dark light mode toggle. Hovering over settings, a little flyout animates out and then allows the user to toggle between light, dark, or the system setting. There are dozens of ways on how to build this, but with Modern Web Guidance, your agent chooses the most modern way. So to give it a test, Phil built this toggle twice, once with Modern Web Guidance and once without. Here are the results. Without modern web guidance, AI built a toggle based on JavaScript as the foundation. JavaScript handled state, the animation, and tooltip positioning. However, JavaScript isn't really needed here. With modern web platform primitives like CSS starting styles, anchor positioning, the light-dark CSS function, and more, all documented through modern web guidance. So when you build the same toggle with modern web guidance, you get a lot speedier result, only weighing 2.6 kilobytes in total and with 0 bytes of JavaScript, while still looking and working exactly the same. So that's just as a quick excursus. If you want to learn more about modern web guidance, go check this link. Now, after this brief excursus on skills as part of DevTools for Agents and then modern web guidance, we'll get back to skills later on when looking at a specific case study. But first, let's finish our tour of the DevTools for Agents architecture. Because the thing we haven't looked into yet, how does any of this, the MCP server and the CLI, actually talk to Chrome? Through Puppeteer, the same library from the Chrome tooling team that you might have used in the past to run tests, automate an annoying workflow, or scrape something. While this layer is mostly invisible when you are using DevTools for Agents, it's helpful to know this, because ultimately, it's Puppeteer giving DevTools for Agents its capabilities. And before we get into those, knowing Puppeteer is the layer in between will also help you better assess security. For example, under one of our recent YouTube tutorials, someone asked, does DevTools for Agents have access to my passwords saved in Chrome's password manager? No, it's not true. The clear answer is no. DevTools for Agents does not have access to passwords saved in Chrome's password manager. It's not using Chrome like you are as a human user. It's only using the vetted and tested skills from Puppeteer. And Puppeteer doesn't expose the password manager as a capability. But also, DevTools for Agent uses a separate, anonymous browser profile by default with no password saved in the first place. And while this largely reduces the risk of the most common security gotchas around giving agents access to a browser, the advice is to always carefully decide what you give agents access to. No matter how boring it sounds, it's critical to protect your and your users' data. Awesome. So now that we've fully explored how it works under the hood, let's dive into some examples and scenarios of what it can actually do. As you just learned, DevTools for Agents inherits its capabilities from Puppeteer. But when you prompt in your coding agent, your agent doesn't directly use the Puppeteer APIs. Instead, we wrapped key Puppeteer capabilities in a set of distinct tools, properly described, and by this, easier to consume for your coding agent. Those tools can be divided into 6 categories in total. In this section, I want to walk you through 3 different use cases, exploring how tools from multiple categories connect to fulfill a prompt. The first example is the one you've already seen, with a prompt like go to localhost, debug and fix the error when signing up. We had the coding agent navigate to the page, fill in the form, and then fix the underlying error and validate its own fix. This example combines input automation, network, and navigation automation tools. For the next example, we are going to combine emulation tools, which allow DevTools for Agents to change the viewport size, for example, and debugging tools like taking a screenshot. Combining them enables your coding agent to do one-off bug validation. So before you manually go through a bugs verification process, let your agent do the work for you. For example, if you have a report about not all navigation items showing up across all screens, you can prompt. Go to developer.chrome.com, check the same navigation items are visible on desktop, tablet, and mobile viewports. After you send, your coding agent will open a Chrome window and use the emulation tools to resize the viewport to desktop, tablet, and mobile, one after another. As a sign of this, in the screencast you see the page occasionally overlaps the window bounds. Then, in this example, Antigravity took screenshots, interacted with the burger menu on mobile, and cross-checked everything before returning a comprehensive answer. The same for navigation items are present across all 3 viewports, and so on and so on and so on. So with this prompt, I could fully automate a testing journey across 3 viewports and nested menus, including interactions, sparing me all manual work and the back and forth to actually remind myself of what I just saw. All right, let's look into one last use case. Chrome DevTools for Agents helps you scale your expertise. For example, let's imagine you don't know much about web performance, just as I when I started web development, or accessibility, or SEO. Now you could go in and ask your coding agent to improve any of those areas with a generic prompt like, improve the performance in this project. But what will likely happen is that your coding agent just slowly starts reading through all of your project files, burning your tokens and only fixing random findings in between, which ultimately might not impact your website's performance that much. But with DevTools for Agents, you can flip it. With its specialized tools to run performance traces, analyze included insights, and run accessibility, best practices, SEO, and agentic browsing audits, it can actually test for known problems instead of trying to guess them from your source code. This allows you to improve you and your coding agent to improve your websites in areas you're not inherently familiar with. For example, you can work on real performance issues by letting DevTools for Agents actually measure your current performance and then work against an actual target and use performance insights in the trace to start where it matters. All through a prompt like, go to localhost, run a performance trace, and act on all findings. Or you can use the same pattern to improve the accessibility of your project, instead of your coding agent and the underlying model just sprinkling random labels in places they don't belong. Or you use the same pattern to ask your coding agent to work on SEO. While all of those examples you've just seen work with the MCP server and the CLI equally, some of them are perfect for the CLI because the CLI can also run outside the agentic loop. This allows you to persist your agent's actions to shell scripts. Here's how it works. After you're done with your debugging workflow, just prompt. Persist your previous actions in DevTools to a well-named script file using the DevTools CLI. And before trying that, make sure that your coding agent has access to the DevTools skills, which teach it about how to use the CLI. For the previous example, where we validated the navigation on developer.chrome.com, this, for example, could yield a script like this, which is opening the page, emulating the viewports, and taking the screenshots. The bit that is missing here is the actual comparison of the results Antigravity has done for me in the screencast earlier. With this approach, that would be on you again. OK, let's wrap up all use cases that we explored. We saw a prompt to automatically fix complex UI flows, one to scale your expertise running performance traces or lighthouse audits, one to validate bug reports, and one to persist your prompted actions to scripts you can rerun outside of your coding agent. To explore more use cases like this and more examples from other tool categories, learn more in our documentation on developer.chrome.com. OK, now all of those prompts we explored combined make a colorful bouquet of individual one-off prompts you can use with your coding agent from time to time, and hopefully inspires you on how to incorporate them into your own everyday tasks. But DevTools for Agents really starts to shine if you incorporate its capabilities in your workflow by default. You can do this by translating currently manual workflows into custom skills, as our partner company Pear did. Pear from Hamburg, Germany, managed to increase their velocity by 10 times and now deploy multiple versions of their client projects per day compared to their previous one release per week. So you can safely say they are the famous 10 times engineers, and you can be one too by adopting what they did. Let's look into it. To achieve this increase in shipping speed, they created a set of 14 highly specialized skills for their agents to use. For example, there's a review code skill instructing the agent to do an exceptionally rigorous high standard local code review. Or there is a Figma validate skill, which enables the agent to iteratively align an implemented design to its original counterpart in Figma. And there is a GitHub issue test skill, which teaches an agent how to validate work recorded in a GitHub issue using Chrome DevTools for agents. Let's look into this one in a little more detail. After defining the general task and a matching role, expert software engineer in this case, the skill breaks down a familiar testing workflow into phases. Those phases will then be executed by the agent, one after another. Phase 1 is issue analysis and state detection. Phase 2 is preparing a plan, as always advisable when working with autonomous agents. Phase 3 teaches the agent how to actually execute the plan by testing in a real browser. And then phase 4 gives the agent the instructions on how to report back. This GitHub issue test skill is invoked whenever an engineer at Pair prompts their coding agent with something like test if issue 1234 is resolved. The actual written skill is pretty detailed with over 120 lines, and I don't want to read them all to you from stage. But let's briefly look into how phase 3 is defined in the skill to give you an understanding of how detailed such a skill needs to be in order to be successful. Before we dive into the details, there is one thing already standing out from this truncated excerpt. Pair defines 3 possible scenarios for phase 3. Scenario A, Chrome DevTools MCP is available. Scenario B, it's unavailable. And scenario C, the agent might need to work more token efficient as it's exceeding its token budget. By explicitly outlining those scenarios, Pair's agent has options. If plan A isn't working, it can fall back to plan B or plan C. If those scenarios weren't defined in advance, there is a high risk the original plan fails for any given reason, with the agent then just wandering off and doing its own thing. That's what you want to avoid if you care about your token budget. Let's explore how those scenarios are defined here in this skill in practice. That's the full segment for scenario A, with only a few truncations. What immediately stands out is a lot of text, as said before, which is necessary for good results because you need to be precise. But no worries, no need to read this all. I want to point out a few details, and then I'll share a link to the source of this and all other skills in a moment. The first bit I want to highlight, if not already obvious, the skill is specific, as scenario A is about using the Chrome DevTools MCP server. The first instruction of this scenario reiterates exactly that. Prefixed with important and calling out explicit tool names, this alone already reduces a lot of randomness in the agent's behavior. And then tool names are mentioned throughout, so the agent doesn't need to guess which tools are best for the task. The next bit is the skill makes it easy for agents and offers shortcuts. As the application Pair's team is working on is behind authentication, they included instructions for the agent on how to quickly get behind that barrier. And again, they did so in a highly specific way. Not only a simple prompt of log in please, but a fast-track tool based on JavaScript the agent can use to quickly continue. And additionally, a reference to more documentation for the agent if it gets stuck. And lastly, the skills instruct the agent to be thorough and not jump to conclusions, but constantly verify its own work through repeated snapshots. So looking at only these small bits of the full skill, we can already identify 3 best practices when you explore the full set of skills after the talk. The first one is guide with precision. Really explicitly state what you want your agent to do and how. This is true for one-off prompts, and it's just as true for skills as well. The next one is streamline execution. Make things easy for your agent. It shouldn't need to implement the same tools on the spot every time to fulfill a task, or repeatedly try searching the web or your code base for the same thing. If you encounter your agent doing thinking or research work twice after invoking your skill for the first time, that's a clear signal you need to update your skill to be more precise. And the last one is demand verification. Instruct your agent to not skip steps and how to check its previous work. Otherwise, there is a high chance it becomes lazy and finishes work with a job half done. And as a good starting point, I highly recommend reading the full case study at this link. The write-up gives a deep insight in how pair and team approached this transformation and includes a link to the GitHub repository with all skills mentioned included. Now, there is one last topic I want to look into with you: configuration. While DevTools for Agents works for most use cases out of the box, there are some configuration options you can use to tailor it to your own needs. To configure it, when using Chrome DevTools for Agents as an MCP server, find the file that has your MCP server's config. For Gemini CLI, this usually was a .gemini settings.json. For Claude, this might be in your project root at .mcp.json. For other agents, it's in similar call files and locations. In this file, just add a new entry to the args array with the option you want to configure. If you're using DevTools for Agents through the CLI, make sure to explicitly include your desired option in the prompt. For example, through the channel configuration option, you can specify whether Chrome DevTools for Agents should connect to any other Chrome channel than stable. Or you can use configuration options to enable experimental options we are still working on, like the recently announced support for third-party tools by toggling the category experimental third-party flag. What a flag name. This allows you to define custom tools for DevTools for Agents by responding to the DevTools tool discovery event, another great name, from your JavaScript. You can learn more about third-party tools, again, in our docs, which are, by the way, written by Zapata, sitting just here up front. And deserved applause. And for the MCP server user specifically, there are configuration options to turn off certain tool categories to save tokens. But there is one configuration option I want to particularly highlight, which is useful for both users of the MCP server and the CLI. It's AutoConnect. Think about AutoConnect as sharing your screen with your coding agent, because AutoConnect allows your coding agent to connect to an already running Chrome instance and pick right up where you left off. Let's look into why this is interesting. For this, let's go back to our initial example. We asked our coding agent to go to a specific page and sign up with test1234. We did this so our coding agent could get the same page state with the error rendering that we already were at. But if I'm already at the exact same state with the error right in front of my eyes, why should I waste mental energy just to write a prompt that gets my coding agent into the same state? Or even worse, manually copy and paste error messages from the browser console into my coding agent. This is what AutoConnect is for, and it works fairly simple. All you need to do is go to Chrome Inspect, select Remote Debugging in the sidebar, and then toggle the Allow Remote Debugging for this browser instance checkbox. Then make sure to use AutoConnect in your MCP JSON config or explicitly prompt for it when using the CLI. Now, the next time you use your coding agent, it will connect to the Chrome you've just been using and will also let you know if it has trouble connecting to it because you forgot to turn on remote debugging, for example. However, this is the right time to repeat the same advice that I gave earlier. Carefully decide what you give agents access to. Because with AutoConnect, depending on what Chrome instance you're connecting to, DevTools for Agents might use your personal Chrome profile instead of the default anonymous one, which puts your personal data at risk. Because technically, connected to my personal Chrome profile, a prompt like go to google.com shopping and order 999 colorful balloons has a high chance of actually succeeding and incurring unintended costs and balloons. Because in this example, I might already be logged into the shop site the agent decides to use, and the only thing it needs to do is click Next all the time. So carefully consider what you prompt for when using AutoConnect. And with this, you have everything to get started. You know how DevTools for Agents works with the MCP server or the CLI. We explored a couple of example prompts, from bug validation to persisting DevTools actions into reusable CLI scripts, and you learned how to configure DevTools for Agents to your needs. Now it's time for you to get started. In the next few slides, I'm going to share resources for you to install DevTools for Agents, learning material to set it up, and how to contribute to it. First up, find install instructions for over 20 coding agents, more use cases, and in-depth documentation through this link on developer.chrome.com. If you haven't seen enough of me today yet, you can also learn more about setting up DevTools for Agents with a video tutorial on YouTube. Find it at Google/DTA Setup. This video is also the beginning of a series of YouTube videos exploring use cases for DevTools for Agents that will expand over the coming months. If you have a particular use case in mind you want to learn about, please find me on social media and reach out. And don't forget, DevTools for Agents is a thriving open source project. If you see something that doesn't work, want to peek into what we currently have in the works, or straight up contribute yourself, please find the project on GitHub with Google/DTA repo. And if you straight up say, I want to use my DevTools I know, I need it visual, there is also something for you. AI Assistance in DevTools UI also got a major upgrade. The AI Assistance panel is now powered by a Gemini 3 Flash and gives more structured visual output. And once you finish your investigation with AI Assistance, it offers a copy to coding agent button, which allows you to export your investigations straight into your own coding agent. So let's wrap up. There are 3 things I want you to walk away with. Install and try DevTools for Agents if you haven't yet. Take the case study you've seen about pair to heart and try to incorporate the learnings into your own personal workflows. And stay up to date with our monthly release notes, and don't wait for the next I/O to hear about everything from stage. We have fun, great stuff in literally every release. Now, that's it. Thanks so much for listening in.